Hello everyone, and welcome to today's webinar on the Sony Pregius S 4th Gen sensor. My name is Manisha Sherbakova, and I'm a sales engineer here at Teledyne IIS. The purpose of today's webinar is to talk about the features of the Sony 4th Gen sensor, what makes them unique, and how they could be useful for your vision application. Teledyne IIS, or Integrated Imaging Solutions, is under the parent company of Teledyne. Here at Teledyne, we have the slogan of Everywhere You Look, because our portfolio covers a very wide range of products that can be found all around you. Our technology can be found in everyday objects like your cell phone, medical scanners, cameras, and all the way up to the International Space Station. Teledyne's wide product portfolio can be split into 4 main divisions: digital imaging, instrumentation, aerospace, and engineered systems. Our group, Teledyne IIS, falls under the digital imaging division. This group is responsible for products ranging from sensors, cameras, image processors and software, all the way to X-ray and RF systems, LiDAR, GIS, and many other imaging components. Teledyne IIS initially started out as a small team of UBC graduates here in Vancouver who came together to form Point Grey Research back in 1997. Eventually, Point Grey was purchased by FLIR and FLIR purchased by Teledyne. Our team has a very long history of being leaders in the machine vision space. The 4th generation of Sony sensors is also known as Pregius S. It is the newest line of sensors from Sony and is a CMOS sensor. It uses global shutter technology and delivers crisp, distortion-free images. This line of sensors is also backside illuminated, and I will go into detail about what that means later in the presentation. This design helps with reducing the pixel size and increasing resolution while improving quantum efficiency and sensitivity. The Pregius S sensor series has several features that make it stand out. As mentioned before, these sensors are global shutter and have a higher resolution. They have a better imaging performance and have good low light sensitivity. They also use backside illumination technology, which allows for smaller pixels and a better QE. One of the main merits of backside illuminated technology is that it allows a wider incident angle. Typically, the drawbacks for designs like this is dealing with noise suppression and dark current. On the Pregius S, Sony developed an original photodiode and light shielding structure to combat these drawbacks. These changes greatly improve the sensitivity and saturation properties and suppress noise generation. It is also possible to maintain the image quality while achieving the miniaturization of pixels, which makes a more compact, high-resolution sensor possible. In addition, adopting a stacked structure that overlays the pixel section and the signal processing section allows to achieve not only a smaller sensor size overall, but also add more functions as a result of the expanded signal processing area. I wanted to quickly jump into the meaning of global and rolling shutter in case there are people that are not familiar with these terms. In a global shutter sensor, the image readout happens for all of the pixels at once. This way, if the scene has fast-moving objects, they are captured as one quick snapshot, so there is no motion blur or drag in the image. With rolling shutter sensors, on the other hand, the image readout happens one line at a time. If the speed of the readout is slower than the speed of fast-moving objects in the image, the object will be dragged out in the image. And you'll be able to see this effect in this video here. Rolling shutter is a great option to go for if you are not imaging high-speed objects because it is significantly cheaper. However, if you want crisp, distortion-free images of high-speed objects, global shutter is the way to go. The first sensor released in the Pregius lineup was the 24.5 megapixel, which is also the highest resolution sensor available in this lineup. The extremely small pixel size of 2.74 microns makes it possible to have very high resolution in a smaller sensor format. Having a single high-resolution camera can often replace several lower-resolution cameras depending on your application. Sony offers some of its sensors in pairs of high and low speed. If you go to the Sony website and look at their list of global shutter CMOS sensors, you will see that some of the sensors have a set of 4. One pair of mono and color sensors will have 1 frame rate, and the other a much higher frame rate. This is because Sony makes a high and low speed version of some of their Pregius S sensors. You can go through the specifications either on our website or on the Sony Semiconductor website to figure out which specifications and sensor would be right for you. The image here compares the pixel sizes of the 4 different generations of Sony sensors. The 4th gen sits at the smallest pixel size of only 2.74 micrometers. With such a small pixel size, these sensors nearly double the pixel density of earlier Pregius sensors. The resulting smaller footprint allows the use of compact, inexpensive optics and makes a 24.5 megapixel global shutter CMOS sensor in an ice cube form factor possible at a competitive price. Lens shading, which is also sometimes referred to as vignetting, refers to the darkening of the edges or corners of an image and is generally undesirable. There are many things that can cause lens shading in an image. It can either be a mechanical reason or an optical design limitation. The mechanical reasons could be that the sensor size and the lens coverage are mismatched, the lens hood is not the right size, or maybe some of the filters added to the lens are not the right size. Some optical design limitations could be the lens aperture settings, the incident angles in the lens, or some internal reflection happening in the lens. The new pixel design in the 4th gen Pregius sensors greatly reduces the lens shading effect from certain lenses on sensor sizes up to 4/3 of an inch. The backside illuminated design accepts incoming light at higher angles, helping low-cost optics produce better imaging. You can see in the image we have a comparison between the 3rd and 4th gen Pregius sensors with the same lens used in both images. The Sony 4th gen sensors combine the low global shutter readout and low read noise of previous sensor generations with the high QE and pixel density of Sitebase sensors. This is displayed by the relative light collecting efficiency of the previous sensor family, the Pregius, versus the newer Pregius S. This improved low light performance means that you can achieve better quality images without spending too much money on a lighting system. The low read noise and improved QE allows you to achieve crisp, clear images in low light. I wanted to quickly touch on some extra sensor characteristics that may be important. On the left, we have a chart that compares the quantum efficiency of the IMX530 4th gen sensor to the IMX250, which is a 2nd gen sensor. For context, the quantum efficiency of a sensor is the percentage of the total photons that strike a sensor that get converted to an electrical signal. In an ideal world, a perfect sensor would have 100% quantum efficiency, which would mean that 100% of the photons that strike the sensor get converted into an electron. As you can see from the plot, the QE of the IMX530 sensor maxes out around the 540 nanometer wavelength with a QE value of over 75%, while at the same wavelength, the QE of the IMX250 sensor is around 65%. The plot on the right shows the temporal dark noise, or simply known as dark noise, for the 4 different generations of Sony sensors. The temporal dark noise is the amount of electrons that are present in a sensor even when there is no incident light at all. In other words, it is the light noise you would see if the sensor was in a completely dark room. Hence, the lower this value, the better. As you can see from the plot, the 4th gen Pregius is roughly in a tie with the 2nd gen for the lowest amount of dark noise. Both the 3rd and the 4th gen Pregius have their advantages, and you can go for either depending on your application needs. The 4th generation of Pregius sensors are great for semiconductor-based applications where a very high pixel density is needed with a good NIR performance, so that the camera can see very small defects in the semiconductor wafer. Metrology applications also require a good precise level of measurement for large objects, so these sensors and their high pixel density and high resolution are well suited. Applications where the camera is embedded in a benchtop device or in a handheld require a camera that is capable of being high resolution but still compact and small. The high pixel density and tolerance for compact lenses makes the Pregius S series a good fit. The Pregius S sensors are available in our camera lineup in the Blackfly S USB, Blackfly S Gigi, and the Forge 5 Gigi range of cameras. There are several resolutions available from 5 megapixels to 24.5 megapixels. You can choose depending on your application if you would prefer a USB or Ethernet interface. We also have a few of the high-speed versions of the sensors in our Forge and Oryx high-speed 5 and 10 Gigi camera lineup. By the way, we did recently lower our prices for the BFS cameras that are based on the Sony 4th gen sensors. You can check them out on our newly launched website, TeledyneVisionSolutions.com, or reach out to your account manager. If you're curious to learn more about our camera offerings, you can visit our website, which I will show you in the upcoming slide. Recently, we announced our brand new website, TeledyneVisionSolutions.com. This website consolidates the product lines from Teledyne FLIR, DALSA, Luminera, E2V, Photometrics, and Princeton Instruments. As part of the new website, we also have a new camera selection tool. This tool can greatly help you navigate our vast range of camera offerings easily. There are many options to filter so that you can organize the list by the camera specifications that are important to you. You can filter by the resolution, frame rate, interface, among many others. You will see a list of cameras that satisfy your criteria across all product lines. Along with our new website, we have also announced our new camera simulation tool, Sitebase. You can check it out at lab.teledynevisionsolutions.com. Sitebase is a state-of-the-art simulation tool that aims to help you figure out the right camera and optics for your application. You can define an image as an example of what you are trying to image and then describe the object size, the smallest detail you want to measure, how fast the object is moving, among other criteria. The tool will consolidate all of your requirements and give you a list of recommendations for both the camera and the lens optics. You can check out the tool right away and even have a free trial to try out the different features. This reaches us to the end of the webinar. Thank you so much for attending, and I hope that you check out our new website to see our camera offerings, and I hope that you join our future webinars as well. Thank you again.